Saturn, the sixth planet from the Sun, is a celestial marvel that has mesmerized humanity for centuries. Its iconic rings, shimmering like cosmic jewelry, make it one of the most photogenic worlds in our solar system. But Saturn is far more than a pretty picture. Beneath its golden clouds lies a gas giant with secrets that challenge our understanding of planetary science. Spanning 75,000 miles in diameter, 9 times wider than Earth, Saturn is a behemoth composed mostly of hydrogen and helium, with a rocky core buried deep within. Its density is so low that it could float on water, a bizarre trait for a planet so massive. Orbiting 886 million miles from the Sun, Saturn takes 29.5 Earth years to complete one journey, its rings glinting in the distant sunlight. Yet, what makes this planet truly extraordinary are its rings, moons, and the mysteries they hold, some suggesting environments where life might exist. Let's embark on a cosmic journey to uncover the hidden wonders of Saturn, from its ancient rings to its enigmatic moons and the groundbreaking missions that revealed them. The rings of Saturn are the crown jewel of our solar system. Stretching over 170,000 miles wide, but often just 30 feet thick, they're a delicate marvel of ice, dust, and rock particles orbiting the planet. Early astronomers like Galileo Galilei, peering through primitive telescopes in 1610, mistook the rings for strange ears or moons due to their blurry appearance. It wasn't until 1655, when Christian Huygens used a better telescope, that the rings were identified as a disk encircling Saturn. For centuries, scientists puzzled over their origin. Are they remnants of a shattered moon? Debris from a comet torn apart by Saturn's gravity? Recent data from NASA's Cassini mission, which orbited Saturn from 2004 to 2017, suggests the rings are ancient, possibly forming 4.5 billion years ago alongside the planet itself, though some argue they're younger, born from a cosmic collision just 100 million years ago. The rings aren't solid, but a dynamic system, with particles ranging from tiny ice grains to mountain-sized boulders, constantly reshaped by gravitational tugs from Saturn's moons. Cassini's close-up images revealed intricate structures, gaps, waves, and propeller features caused by tiny moonlets embedded within. Surprisingly, the rings are 90 to 95% water ice, sparkling brilliantly, but tinged with dust that gives them a golden hue. In 2025, scientists are still debating whether the rings are eroding faster than expected, potentially vanishing in a few hundred million years, a cosmic blink. Saturn's atmosphere is another spectacle, swirling with golden and beige cloud bands. It's driven by winds reaching 1,100 miles per hour, faster than any hurricane on Earth. At the planet's north pole, a bizarre hexagonal storm, discovered by Voyager 1 in 1981, spins like a geometric enigma. This six-sided jet stream, wider than 2 Earths, is a meteorological marvel with no clear explanation, though scientists suspect it's caused by complex interactions of atmospheric waves. Cassini later captured its vibrant colors, revealing a swirling vortex at its center. The South Pole, meanwhile, hosts a massive hurricane-like storm with an eye 50 times larger than Earth's biggest cyclones. These storms hint at a turbulent world beneath Saturn's serene exterior, where pressures deep within may crush hydrogen into a metallic state, possibly driving the planet's powerful magnetic field. Saturn's moons, over 140, with 83 named, are a cosmic zoo of diversity. Titan, the largest, is bigger than Mercury and Earth's moon, with a thick nitrogen atmosphere denser than Earth's. In 2005, the European Space Agency's Huygens probe, carried by Cassini, landed on Titan, revealing a world with methane lakes, rivers, and rain, an alien Earth with liquid cycles unlike ours. Titan's surface, shrouded in orange haze, hosts stable bodies of methane and ethane, some as large as Earth's Great Lakes. Organic molecules in its atmosphere suggest chemical processes akin to those that preceded life on early Earth. Could Titan harbor microbial life in its subsurface water ocean, locked beneath an icy crust? Enceladus, another moon, stunned scientists when Cassini detected geysers of water vapor and ice erupting from its south pole. These plumes, shooting from subsurface ocean, contain salts and organic compounds, making Enceladus a prime candidate for life. In 2025, NASA is planning future missions to sample these plumes, hoping to find biosignatures. Other moons, like Mimas with its Death Star-like crater, or Iapetus with its two-tone surface, add to Saturn's gallery of oddities. A surreal depiction of Titan's subsurface ocean with glowing chemical reactions under an icy crust, alongside Enceladus geysers spraying organic molecules into space in a vibrant astrobiological style. The exploration of Saturn began in earnest with NASA's Pioneer 11 in 1979, the first spacecraft to visit the planet. Flying by at 71,000 miles, it sent back grainy images of the rings and confirmed Saturn's magnetic field. The Voyager 1 and 2 missions in 1980 to 1981 provided sharper views, discovering the hexagonal storm and new moons. But the Cassini-Huygens mission was the game changer. Launched in 1997, Cassini orbited Saturn for 13 years, completing 294 orbits and sending back 453,000 images. It mapped the rings in unprecedented detail, discovered 7 new moons, and studied Saturn's seasons, which change every 7 years due to its axial tilt. Cassini's daring grand finale in 2017 saw it dive between Saturn and its rings 22 times, collecting data on the planet's atmosphere and ring composition before plunging into Saturn to avoid contaminating its moons. The Huygens probe's descent to Titan remains the farthest landing ever achieved, offering humanity's first glimpse of a moon's surface beyond our own. These missions revealed Saturn as a dynamic system, not a static gas giant. Recent discoveries continue to reshape our view of Saturn. In 2023, reanalysis of Cassini data confirmed that Enceladus Ocean contains phosphorus, a key element for life, strengthening its case as a habitable world. Scientists also detected seasonal changes in Titan's methane lakes, suggesting active weather cycles. In 2025, the James Webb Space Telescope, JWST, turned its infrared eyes on Saturn, capturing details of its rings and atmospheric composition with unprecedented clarity. These observations hint at trace gases that could reveal more about Saturn's interior. Meanwhile, Saturn's rings are showing signs of ring rain, where charged particles spiral into the planet, potentially depleting the rings over millions of years. Future missions like NASA's proposed Enceladus Orbilander or Titan Dragonfly, set for launch in 2028, aim to explore these moons up close, searching for signs of life. Could Saturn's system hold the key to understanding life beyond Earth? Titan's organic-rich surface and Enceladus' watery plumes make them prime targets in the search for extraterrestrial biology. Saturn itself, with its extreme conditions, challenges our models of planetary formation. Its low density and massive ring system defy easy explanations. The planet's magnetic field, aligned unusually close to its rotation axis, puzzles scientists, as does its rapid rotation, completing a day in just 10.7 hours. As we look to the future, private companies like SpaceX are eyeing Saturn's moons for robotic exploration, while concepts for floating habitats in Saturn's upper atmosphere, where pressures mimic Earth's, spark wild speculation. We hope this cosmic odyssey through Saturn's wonders has ignited your curiosity. Stay tuned for more space adventures. And don't forget to subscribe for the next chapter in our journey through the cosmos.